Well, yes, it's not an entirely different world, hopefully. I think there is actually quite a lot of overlap. There's certainly nods from Tom's talk earlier, and yeah, in terms of AI, I think it's interesting to think of this in the context of yeah, making it AI explainable and how we can maybe like link engineering models with knowledge models to gain the benefits for especially safety critical systems in this case. So that's a little getting a little ahead of myself. So my name's Stephen Powley. I'm a PhD student at Coventry University, just writing up, and this is a very whistle stop tour through my PhD, which will be completed very soon, hopefully. So today I'm going to talk about multi-context model-based ontology engineering. The context that I'm doing this in is automotive cybersecurity and safety. So we're thinking of safety critical systems, security critical systems, high resilience, high rigor. Research questions are started around enterprise capability and what kind of enterprise capability you needed to deliver secure connected vehicles. So I asked a number of experts, and they helped me identify some key practices in context, which helped me narrow my focus down to standards, and then develop this approach called multi-context modeling, which is a way of modeling and mapping standards at the semantic level based on the vocabularies. And to do that, I needed to have a way to understand and model concepts and semantic relations. I needed to be able to create a UML meta model because all the systems engineering is UML based in SysML. But it also needed to be able to talk to the semantic web and take advantage of all the wonderful ontologies that are out there on the semantic web and connect the engineering and the knowledge worlds. And to explain how this is worked, there's a quick case study I've done with the ISO road vehicle cybersecurity harmonization task force. Are you seeing me okay? I've just had a slight change at my end.
Yes, we're seeing your slides.
Okay, so the modern connected vehicle operates in a very complex environment. It's not enough just to think about the car as a box and the manufacturer's responsibility stops there. They have to have like through life monitoring, continuous updates, means for connecting, contacting customers, providing updates. It's a very complicated world, and it has to be very rigorous in order to protect it from malicious actors. So I asked which conditions in the enterprise enable connected vehicle security by design and default through the life cycle. The answers came back that standards and regulations are really important. Automotive is super standards focused. It's pretty similar to finance in that respect. So that there's some parallels with that earlier talk. Systems thinking was really important. We have to use systems engineering. We have to connect things like legal into the engineering process. We have to do due diligence. You have to like be very rigorous, have strong policies and procedures, and all of that is in place really to build evidence-based trust. In order to do that, yeah, we need a harmonized approach across jurisdictions because automotive is a global activity. We have to collaborate and co-create. This is too big a problem for anybody to do on their own, even a big organization. And that collaboration needs to be between academia and industry because it's such a new world and such a fast-paced world. So my focus was on the standards. People also told me about things like building expert teams were important and training people in cybersecurity. Wasn't something I could really affect with my PhD. So I focused on the standards and the fact that the standards weren't interoperable. And so we needed a common semantic layer that the standards could work on if we were to hope to start integrating systems engineering, software engineering, cybersecurity, and all these other aspects. So there were a number of key standards that I was going to focus on from a case study, but it also became apparent it was really important to be able to connect this to the semantic web. There's a lot of great work being published there, and the two worlds really need to talk together. So, oh,
Yes, you are there.
sorry, it's got yeah, multi-context modeling. It's about different communities with different vocabularies. Sometimes use the same term to mean different things, different terms to mean the same thing. But more broadly, they have different worlds of view, ways of viewing the world, and its concepts. So that translates into worldviews and ontological commitments. So if we're just to do this model-based ontology engineering, then we need to be able to connect context, but all of those 3 bullet points have to be accommodated within the same model. And if we do this, it provides the groundwork for what we call digital transformation initiatives, which connect enterprise tool sets. And that's the kind of transformations that a lot of MDE people are very good at. So the benefits are that we resolve issues across different domains. We take an integrating approach, which makes assessment and audit a lot easier. Prelude to harmonizing primary lifecycle processes. So if we want the software people to be doing things that benefit the systems engineering team and vice versa, they have to have harmonized processes, but they have to be operating on the same objects in order for the processes to make sense. So all of that will reduce waste, increase reuse, and this idea of curated engineering knowledge that provides that rigor, but connected to the knowledge base. It can also provide a guide for explainable AI. So there's a lot of research going on now about ontology engineering, and linking that in with language models to provide a bit more structure that the language model can use to explain its thinking. So one of the semantic web technologies that came out last year is called MVF, stands for Multiple Vocabulary Facility. I'm in the middle of transitioning from beta 1 to beta 2, so there's a bit from each if you're paying close attention. The basic idea is you take a source vocabulary, a set of source vocabularies, you map them to concepts. So you notice there's lots of lines coming into a single concept. One of the use cases is, for example, if you have multiple languages, so you want your Chinese engineer to be able to understand a modeling element that was created in French by a French engineer, yeah, that would be supported. But also if you've got different communities within the same spoken language who have different ways of understanding the world, it can be very useful, and that's the way that I'm using it. And then on top of all of that semantic and mapping, you can build an engineering model where you can do the heavy curation. So at the concept map level, there's no real transitivity. So if you want to enforce transitivity, then you need to build the engineering model on top of it. MVF is quite simple. It's only got 11 classes. One of them is really an attribute. So 10 classes and a bunch of relationships. I'm going to focus on this bit, which is the idea that you have an MVF dictionary with the maps to a vocabulary and MVF entries mapped to vocabulary entries. And in particular, I'm going to look at relations between entries and expand on the way that it's done in MVF, because for the curated engineering models, it doesn't give us enough richness to get started. So I use Chemio Systems Modeler because it has an OWL importer, which is like a super useful piece of technology, and it'll also create the OWL from the UML as well. So the first ontology I imported was MVF, and you see we get SCOS for free with MVF alongside a load of other semantic web stuff. MVF is actually 3 ontologies, and 2 of them implement parts of ISO 1087. The bit I'm not talking about today, but a few of you may know I'm interested in foundation ontologies, and there's a semantic web version of the unified foundation ontology, which I'm using to develop the meta model for context modeling as opposed to the vocabulary modeling. Today I'm just talking about the vocabulary modeling. So the model structure for my meta model and profile looks something like that. And the MVF meta model is built by making a bunch of assertions. So there's an XMI version and an RDF version, which are not identical, unfortunately. So there's some fixing going on there as well. There's an idea of an MVF element, and you can see here that there's SCOS concepts. So it's a very big model. I'm about 50-60 diagrams, but it's basically a bunch of assertions like this. And then the UML profile I built is all traced back. So every class is mapped to an RDF class. Every relationship is mapped to an RDF property, which has been imported by Cameo. And all the attributes of the classes in the profile are mapped to RDF properties. So everything should be two-way traffic. So any engineering model you build on this should come with the RDF capability for free. That's the idea. So the MVF ontology broadly looks like that, and you can see how there's some dependencies there to show how the meta model maps to the profile. SCOS provides mapping relations. Now, mapping relations, unless they're exact match, are not transitive. And this is, as I said before, this is really important. So when we're building these vocabulary maps, we're not asserting transitivity. That's why you've got the model layer on top of this way. But what we can do is make the task of the people doing the hardcore engineering much easier by having expert domain discussions about the relationships between the terms. And what I've done is develop this extension to SCOS. So as well as close match, we allowed loose matches, because we found with the standards, somebody calls it a system element, somebody calls it a component. We need to be able to understand how they relate, but there's not enough information to say that they could be transformed. So transform all those Venn diagrams into a top level profile. Looks like this. There's a bunch of engineering here to make sure that not everything is based on an association, because association shouldn't be the basis for everything. So you'll see there's like directed relations, and it makes a much cleaner model semantically. So that vocabulary mapping exercise, once you've got all that infrastructure, you need to talk to the experts. You've got to talk to the domain experts. There's no point trying to map standards just sitting down if you've had no involvement, you've got no expertise with that standard, you don't know the domain. You've got to have those experts, and to do that, that's that point earlier on about getting involved. So I volunteered with the working group 11, and I've been on the committee, and I'm talking to OMG about some possible updates to MBF. So none of this would be possible without those communities that I joined. So it's important that I thank them for all that they've enabled. But what we did find, even for the people who are not modelers, who are not ontologists, conceptual models were very useful. But you have to show it in really bite-sized chunks, 1 or 2 triples at a time, and then you can walk people through it. And then when you show them the bigger diagrams, they're not scared by it. And all of those considerations are really important. So what do you end up with? Well, you end up with standards where you've identified some candidate terms that you want to line up. Then, because every engineering project needs a spreadsheet, there's a really complicated spreadsheet. This makes a much more familiar interface for the engineers, and it doesn't take any explaining, and it obfuscates the modeling, and it looks familiar. But with it being a spreadsheet, it's very easy to import the relationships, and they're all automatically generated by drop-down boxes. When you create that in the model, these diagrams, something like Cameo Modeler will have a decent stab at generating the diagrams, but you do need that curation as well. and you end up with a bunch of diagrams that look like this. And you can see that three very important standards for automotive software engineering and systems engineering use very, very similar terminology, but have very loose relationships between them. So if you were making the assumption in an audit that the system you'd created using automotive software, automotive spice, then that was similar to the system in 26262, you'd have problems because they're not identical. So yeah, the nice thing to do would be in an ideal world, perhaps sort that out so everybody has the same meaning. We've done an extensive exercise on that using the mapping spreadsheet and a bunch of ontologies based on the standards. Yeah, it's a great idea, but you need to be very, very targeted. It's extremely hard to do it even for two standards here. So it is possible. Intelligent Transport Systems Community did it. They got 12 working groups together and produced a model-based vocabulary for the entire technical committee. It has been done. But it's very hard. If you're tempted to do this, please remember the advice of Rudolf Carnap, which is that if you're interested in the relations between fields, then you will not be welcomed as a builder of bridges, as you might expect, but you'll be regarded by both sides as an outsider and a troublesome intruder. Now, that doesn't mean it's not worth doing. It just means forewarned is forearmed. And in summary, you've got to understand the context, but you need to model all the contexts together. To do that, you have to listen to stakeholders. You can't just do it as a desktop exercise. Collaborate, participate, develop talent, make it semantic web compatible so that engineering can take advantage of all the reasoning and all of that that's made available by semantic web tech, but that you have the heavy curation that is required for the rigor. Value adding transdisciplinarity is really something else that comes for free with all of this. It's familiar to anybody who's doing model-based systems engineering, but also familiar to people who are ontologists. If you're going to do this in your domain, I recommend doing case studies, not only to demonstrate the value of the method, but to also demonstrate how much hard work it is to yourself. But if you take all that on the chin, then experience suggests that you can influence and improve global standards.
Thank you very much.